We are also live on YouTube. I think people will keep joining in, but we should definitely get started. So, GM everyone, this is today we'll be covering Polyrap as part of the Eat for All workshop series. And to help us out with that, we have Jordan and Neeraj from the Polyrap team. So, Jordan is one of the builders at Polyrap, and Neeraj is a software developer at Polyrap as well. And just a fun fact, Neeraj was also one of our fellows from the ETH India Fellowship. So great to see builders helping other builders win those bounties, which a lot of people are excited here to know about. So yep, in the interest of time, we'd like to get started. So over to you, Jordan and Neeraj.
Awesome. Yeah, thank you for the intro and really happy to be here today. And so I'll go ahead and I'll share my screen and we'll get started. So let's get started. So Polyrap, our goal is to bring about a new future in software that is more composable. And so it's a new way to build that allows your software to be endlessly extendable. And it can run anywhere. And so we'll talk a bit more about what that means. So what exactly is Polyrap? So Polyrap aims to be a universal interface. Wrappers let you compose software like never before. All of this is done by simply adding a Polyrap client to your application, similar to how, let's say, you would add an HTTP client to your app to send web requests. You can add a Polyrap client to your application to be able to fetch and run wrappers, which are little software modules. And all this is done through the use of secure WebAssembly. And so these WebAssembly programs allow you to read and write to any protocol. And so, just going through a few quick examples of what this might look like, very basically, you would, build a wrapper for, let's say, Uniswap. And then you can then integrate that into any language that you may want. Today, we have support for JavaScript and TypeScript running in Node.js and then also the browser, as well as we just released like our Rust client, as well as our Python client. And then we've also been doing some preliminary experiments using the Rust client in both Android and also iOS mobile environments. So the idea here is to be able to build a single wrapper that can be run anywhere. And so here, with Uniswap, also with IPFS, you can see that it's a very similar interface. And the idea here is that after you build your wrapper, you can then basically generate code in any language that you want to integrate it in, and you get a very native programming experience. So here you can see that we're interacting with the IPFS wrapper instance, and we're calling the cat function, and it's fully aware of the arguments that we're passing in. But behind the scenes, it's actually using the Polyrap client to be able to perform these wrapper invocations. So we'll talk more about that throughout the workshop. And then lastly, to just show that this isn't just about, using a single blockchain or using a single network, you can do anything with these wrappers. So you can also interact with other blockchains, like for example, Near. And so anything that you can do inside of a traditional SDK, let's say a JavaScript SDK, you can also do inside of a wrapper. And so the goal here is to be able to break down software silos. So instead of building a whole bunch of different SDKs in different languages, you should be able to just use one and easily integrate it anywhere. And so some additional benefits that we'll walk through is first off, security. So wrappers are more secure than traditional SDKs. This is because WebAssembly runs in a secure virtual machine, a secure sandbox. And so the WebAssembly bytecode cannot access memory outside of itself. And so if you have, let's say, private keys in your application or, sensitive system permissions like network access that you don't want to give to your wrappers, that's all possible. Wrappers do not have kind of like built-in access to anything off the bat. And it's all based on what the application gives it access to. So you have full control over giving it access to networking, giving it access to file system, however you see fit. And all of that is fully programmable through the use of plugins. And so that's another concept in Polywrap, which you'll learn about as you dive in. Also, wrappers are easily composable. So they all have, as stated earlier, a consistent interface. And so this allows you to use multiple side by side. You can wrap one on top of the other, or you can create an aggregator of sorts, which pulls in many different implementations of a single interface. So there's lots of different composability options here due to the use of these standard interfaces between the software modules. Wrappers are also upgradable. So these wrappers running inside of your application can be fetched on demand. And so let's say, for example, you're writing a smart contract protocol, and you also want to publish an SDK for this smart contract protocol. Well, it is very hard to, let's say, make a smart contract upgrade that may affect your SDK in certain ways that need it to change when you have a whole bunch of integrators that are using your SDK in their applications. So this is a common problem with lots of big protocols, big smart contract protocols, like let's say the MakerDAO system. Whenever they create smart contract changes, they have to kind of go out to all of the third parties and say, hey, upgrade your SDK. But with wrappers, you can publish wrappers to an ENS domain, for example, and the applications integrating the wrapper can fetch the latest version from a specific ENS domain, let's say. So in a single on-chain transaction, you can upgrade your smart contracts and upgrade your SDK. And then all of the apps all over the world that are using your SDK would be effectively updated. So they wouldn't have to rebuild themselves and relaunch themselves. And it's also worth noting that this upgrading functionality can actually be turned off if you want. It's totally possible to just completely embed the wrapper in your application so it's static and it can never change. So there's a full range of possibilities here. And then lastly, wrappers are more scalable than traditional SDKs. So this is because when you're doing this fetching of on-demand SDKs, you can actually offload, you can garbage collect SDKs that aren't being used. And so these wrappers can be taken out of your application's memory, and that allows you to run in a more lightweight fashion. And so this theoretically allows you to have an infinite number of integrations inside of your application without creating an enormously large bundle size for your app, or resorting to running a central service to do this aggregation for you. And so the existing wrapper ecosystem is just getting started. You can learn more about it at awesome.polywrap.io. This awesome repository that it'll bring you to is actively under development, but this is going to be the central place where we kind of keep track of all the amazing things happening in the ecosystem. And then as far as the bounties and the tracks that we're sponsoring, first off, the best Polywrap integration gets a $500 prize. And so this is for using an existing wrapper inside of an application in the coolest way possible. Also building the best new wrapper. So whoever builds the best new wrapper, another $500. These are both single prizes. And then there is a prize pool of $500. And this can be up to 8 different teams. So any project that successfully integrates with Polywrap can win a piece of the prize. And it's up to $1,000. Okay, I actually made a typo here. Sorry about that. This should be 1,000. And then 8 potential winners. Cool. And so let's dive in. Let's start with the workshop. So I'm going to be walking us through an awesome demo repository that Niraj had actually just built for us. It's here at ETH Simple Storage template underneath Polywrap. And yeah, let's go ahead and get started. So everything that you need to know can be found inside of the README. If we check this out, sorry, Zoom is blocking my space. Let me move this. Okay. And so inside of the README, you can find some cursory information about what's inside of this repository, which I'll walk you through. And then also we have a full guide so that you can actually go through the steps that I'll take you through today on your own machines to see if you can get this all running yourself, which you should be able to. So let's get started. So first off, in this repository, we have 3 different folders to keep track of. We have the wrapper folder, which is where the wrapper exists. We also have a hard hat folder, which is where our contracts exist. And then we have an application folder. And so for the wrapper, we also have 2 different languages that are, just very simple examples of building a wrapper. One is in Rust and one is in AssemblyScript. And so let's go ahead and get started first by building our contracts. I've already gone ahead and installed all dependencies, and so that's all done with. And so we can just get right into it. And so if we go into the hard hat folder and we run yarn compile, we'll go ahead and we'll build our contracts. And the contract that we're going to be building is a very simple one. It's the simple storage contract. And we're going to be showing you how to build a wrapper around the simple storage contract and integrating that into your application. And so here is our contract. It has successfully been built. And so now let's go ahead and run yarn dev. And so yarn dev is going to start up a local blockchain. It comes with these existing accounts that are funded with test ETH. And so part of the setup instructions is to take one of these as private keys and add it to your MetaMask so that you can properly use the application in the later steps. And so I've already done that. And then additionally, at the top here, we can see that the simple storage contract has been deployed. And so this address exists. And so this address is consistent. It doesn't change. And if we actually search the code base for this address, we'll see that we're using it, for example, inside of our application. So this is how we're going to be interacting with this testnet contract. All right, so now that we have started up the chain, we've built our contracts, let's get going with building our wrapper. So we're going to change directories into the wrapper. Again, there's an AssemblyScript wrapper and a Rust wrapper, just to show you what these wrappers look like, so you can start to understand what a wrapper looks like. First off, you'll see that there's these polywrap manifest files at the root directory. If we click on one, we'll see that projects have names. They also have a type, and so this is a WASM AssemblyScript wrapper. In the source section, it shows you where the root of the module is, as well as where the schema is. And then lastly, there's some project extensions, which here we have like a build extension with some custom build settings, a deploy with some custom deploy settings. And then also we have a test manifest. And so this is a manifest that can run tests against your wrapper. And so we'll show that in a second. And then probably the most important piece of your wrapper is your schema. And so this defines the public interface of your wrapper. At the top here, you'll see that it's a little different than traditional GraphQL. So we use GraphQL just because it's a very commonly understood syntax for writing interfaces. But we build on top of it and we add our own features. And so here at the top, you can see an import statement, which allows you to import the module and also other types from this URI into this namespace. And so we can name this whatever we want. And today we're going to be calling this Ethereum because this is the Ethereum wrapper. Also, you'll notice that all wrappers can be addressable through this URI. And so that's another core concept of Polywrap, is the concept of a URI. The same way that a web page has a URI, wrappers can have a URI. And it can also be anything. So here we're showing an example of ENS, but you can also add IPFS and then do like a hash. You could also do HTTP and then do some domain. So there's a full range of possibilities for how you want to basically address your wrappers. And then lastly, we have our functions. So we have get data and then set data for both of our functions of our wrapper. When we run the CLI, so let's actually go ahead and change directory into assembly script. Let's do yarn code gen. So this runs the polywrap code gen command, which will generate our types for us from our schema. And all these types get put into the wrap directory. And so all that we have to do is simply implement the functions in our schema. And as you can see, we can pull in these types from the wrap folder. And so here we're exporting a get data function and also a set data function as it existed inside of our schema. And then we're implementing the logic inside of it. And again, like this logic could be anything. But the important thing to note is that this is running inside of WebAssembly. So you wouldn't be able to, let's say, like import, file system from FS or something like that, like you would in Node.js. And it's also important to note that this is assembly script. So it looks a lot like TypeScript. It looks a lot like JavaScript, but it's actually a custom set of, functionality to be able to be compiled to WebAssembly. So you'll see that we can use these WebAssembly types like U32. And then the other thing to note here is that we're interacting with the Ethereum module. And so this is the wrapper that we had imported. And so when we actually call this function, it's going to actually do a cross module call. So our simple storage module is going to then call into the Ethereum module, which is running as a separate WebAssembly instance. Yeah, so let's go ahead and get started with building this. So if we run yarn build, it's going to run a build. I've already done this, so it should finish very quickly. You'll notice that it's running some Docker commands. And this is because we use Docker for being able to build wrappers consistently. And this is because when you're building WebAssembly, there's also some other system level dependencies you may need to be able to build a proper WebAssembly module. And so we kind of handle this all for you through a Docker image. And so as long as you have Docker running, which I do here, we have this image, which is a polywrap VM, which has all your build dependencies, and your wrapper will just build like magic, no matter what operating system you're on. So this should work just fine on Windows or on Mac or on Linux. Wherever Docker can run these images, you should be fine. And so now that we have our wrapper built, it's just finishing up right now. It'll spit out into the build directory. And so I'll just give it a few more seconds for it to finish up. We can start talking about what's in the build directory. And so this wrap.info file, it is an encoded file. It's actually encoded in message pack. And so let's see if I actually, yeah, okay. So I have message pack to JSON. So here we've converted the message pack to JSON, and we can see what the different types in our ABI are. And so wrappers, just like smart contracts, they have an ABI. And this info file, this ABI file, represents what is inside of our WebAssembly file. And so WebAssembly is binary, and so we can't look at it right now, but we can certainly run it. And so let's go ahead and do that. If we just go ahead and run yarn test, it'll run two different sets of tests. So this example is showing you how to actually test your wrapper in two different ways. The first way is through a way that you might be familiar with, which is just through JavaScript-based testing. And so here you can see we have like describe, and we're using jest. And so inside of this test, we're just going to go ahead and interact with our wrapper. And when we interact with it, we call the get data function, and then also the set data function. So this is going to be calling the get and set on our wrapper. And as we recall here, get calls the get function on the smart contract. Set calls the set function on our smart contract. And so, this had completed just fine. It passed. And then also down here, we run the polywrap test command. And so this test command runs over this test manifest. And this is basically just a YAML file that fully describes your test as it runs. It tells you what wrapper it wants to run. So the URI is file system build directory. So it's telling it to go to the build directory where your wrapper was built. And then it tells it the function to call, and then the arguments to input to that function. And so these both ran to success. And we can actually validate the output by using something called Q. So Q is another great markup language for being able to kind of self-describe sanitization for output. And so we have two different tests here to sanitize what the output data should look like. And both of them finished successfully, so that's great. Sweet. So we have our wrapper built. We have it running tests just fine. It's all working. And so let's now move on to the final piece, which is using the application. So if we change directory into the app directory and we run yarn start, we'll go ahead and we'll get an application set up. Let me make sure that I'm on the test network. Let's do localhost, and then I'm going to go to this account. And so this account was the private key that I had grabbed from the console when we set up that test chain locally from Hardhat. And as you can see, I have plenty of test ETH. And so when we start up our application, it's actually going to fetch what the current storage value is. If we refresh this, it'll show the same thing. There we go. So our storage value is 100 currently, but we can go ahead and we can, call a new set on the local contract instance. So we go ahead and confirm the transaction. And then our contract should update. Let's see.
Hi, Jordan.
Yeah.
I think that's the non-error because you need to reset the account.
Yeah, you're right. Thank you for that. Let me go ahead and do that. It's under settings. Yeah, reset.
Yeah, and also make sure your chain is up to date. You can reset chain also, so there is no issue.
Yeah, that's a good point. I think that the chain should. Okay, yeah. There, let me try really quick. I think we should be good.
Yeah, and
yeah. Okay. Sweet. So we were able to make a test transaction on our local chain. If we look at the output from Hardhat, which this is a revert. Okay. Yeah, it looks like we're getting some reverts from the call. But we did get a successful transaction. And additionally, if we wanted to try this on, for example, Goerli, we can try that as well. So we've deployed this simple storage contract also to the Goerli network. And so if we just go ahead and refresh the page, for your own applications, you can go ahead and implement better account handling than this. If we update the value on Goerli to, let's say, 7, we can go ahead and sign that transaction. all working. And then, we can see the transaction on Etherscan. And if we actually look at what the source code for the application looks like, we can see that inside of our app, we're calling, well, first off, in our views, we have the storage value, which gets the value. And then we have a button, which when clicked calls the set data function, which passes in the client. So we go ahead and we get the PolyWrap client. And so that's the first step, is being able to set up your PolyWrap client correctly. And so here, as you can see, we configure our client with the client config builder. And so this builder has lots of useful functions for being able to configure the client. We have default configurations that you can add to your client. And then additionally here, we're adding our own Ethereum plugin. And so we specify the URI for Ethereum. And you'll notice that this is the same URI as is in our wrapper. And then we pass in this plugin. An Ethereum plugin is something that is a JavaScript module. And it holds the connection object, which is able to reference your JavaScript provider. And so when we add this to the client, our wrapper can now actually send transactions through that MetaMask instance that's in your window. So because of this plugin, we're able to connect WebAssembly to your browser's MetaMask. So that's kind of how the connection is made there. And then after we create this client, we will go ahead and call the set data function. And so this set data function, it's using the client directly through the invoke function. And the first thing it passes in is the URI of the wrapper that it wants to invoke. And so this would be your wrapper that you built and deployed. And then also the function that it wants to call. And it's also worth noting that if you don't want to access your wrapper from an external URI, like let's say an IPFS URI or something like that, you can be able to, you can also embed your wrapper directly inside of your application. And so more information can be found on that inside of the docs. And then also feel free to, just message us in Discord and we can help you with all that. And then also down here, you can see we're also calling the get data function in the same way. So this sort of client invoke syntax doesn't change, based on the language you're working in. And so in Python or in Rust, let's say, you would also have a client and you could call the invoke function. And if you look on our website, we actually have examples of that, as well as, well, yeah, here, let me just pull that up really quick. And then that'll basically be the last part to this talk. Yep, so on our website, you can click this little button to show the client invoke syntax or the code gen syntax. So this is the code gen, and this is kind of the behind the scenes. And so you can see that in TypeScript or Python or Rust, it can all look the same. So that is a quick overview of PolyWrap. Thank you so much for coming here today and listening to it. And hopefully we could maybe have a few minutes for questions, but I'm not sure. But yeah, that's the end of my workshop portion. And also thank you to DevFolio for putting this on.
Yep, definitely happy to help. I can see that Neeraj has answered most of the questions via text, but there are still 2 open questions on the Q&A box. So I can just read it out for you. First question is, how can we import any other protocol? Can you please also show that in the demo?
Okay, awesome. So importing other protocols would be through just importing other wrappers. So the same way that in, let's say, JavaScript or in Rust, you would import other packages, other crates, to be able to access that logic. So the same thing applies here. For other Web3 protocols, we have support for IPFS, Ethereum, Near, and then also for Tezos and Substrate. There have been some initial developments there. And that's just kind of on like the protocol level. There's also more for smart contracts, like we have like a Gnosis Safe wrapper, a Uniswap wrapper, things like that. So if you want kind of an initial list of these different protocols that exist, you can check out our repositories, and then also the awesome list that was mentioned in the call.
Hey Jordan, can you show them the live example in like import some module in the GraphQL and show the code gen so that they understand, like it's very easy to import any module.
Okay, yeah, sure. How much time do we have really quick?
We can take some time for questions, so it's all right. We can.
Okay. All right, cool. Yeah, so let's just go ahead and if we jump into the wrapper directory. Oops. Sorry, with all this stuff on my screen, it's getting hard. Okay. If we go to the wrapper, if we go to the schema, up here in the schema is where you would import any of the dependencies you want to use. And so let's just go ahead and let's find a random one. So wrappers can be found on wrappers.io. This is just an initial list. And so we have, let's see here. I'm trying to find one that would be an easy one to show. Let me show actually.
You can use logger.polytext.
Yeah, but okay, yeah, that's a good point. But sorry, I don't think that's set up with the URIs with the default. So here, let me just show the compute Fibonacci. So this is like a fun little wrapper, which just has a very basic function, which is compute Fibonacci. You can see its schema here. And so since this is just deployed on IPFS, we can import it from there. So here, let's also just use the import star syntax into fib from IPFS/that. And so here we have gone ahead and imported the Fibonacci wrapper. If we call yarn codegen, it will import that wrapper and then generate bindings for it. And so inside of our wrap folder, inside of imported, you can also see that now we have fib module. And so inside of our code, inside of our code here, let's do something fun. Instead of passing in the data for set, inside of set data for the value, let's go ahead and compute the Fibonacci value instead of just the value that's passed in. And so let's do fib module. We'll import fib module. And as you can see, this type now exists. We can call compute Fibonacci. It expects an n. And so we can type args.value, which is our n. And then this will return a result. And so unwrap that result. And the result is an array of integers. And so we're going to get the last value, which is fib.length -1. So we're going to get the last Fibonacci value, and then we're going to pass that into our value that we set on chain. And so now, if we build our wrapper, we can see this actually work.
Yeah. Yeah, I think we can't show that on app, but we can show it in test because we need to deploy this in the provider.
Yep. Yeah, exactly. And so
Yeah, and meanwhile, while that's building, there is also another question about, can we specify IPFS gateway details to a plugin?
Yep, absolutely. So let's look at that maybe next. Also, we just recently answered this question in our Discord, and so if you ask the question there, we can point you to the full thread where all the details are. But yeah, it's fully possible. Let me. Where should I show that? Let me quickly pull up. If you go to Origin 0.9, since that's the version we're using, if you go to the config builder, if you go to that default bundle, the default config, we have an example of that here, wrappers.io. So these are the initial default IPFS providers. And then we pass them into the environment. So wrappers have an environment that can be configured on them. So these are the environment variables of this wrapper. And we can go ahead and set it like so. But again, feel free to ask in the Discord and we can help you more hands-on. Cool. So we've gone ahead and built our wrapper. It's in the build directory. And so let's run test and we'll see our test fail because the number is no longer going to be correct. And so here it expected 0, but it received 6. This is also because we haven't reset the chains. Let me reset the chain really quick. Okay. Okay. So this is what we would expect. It expected 10 to be set, but instead 55 was set. And so that's because 55 is the last digit of 10 Fibonacci numbers. And again, like what had happened here is when the Polywrap client runs this wrapper, it's going to receive the request to execute the Fibonacci module, and then it's going to go out and fetch it really quick and then run that Fibonacci module. So this is kind of a cool example of showing, a single wrapper interacting with multiple external dependencies. So I hope that answered some questions there. Cool.
I don't think we have any other questions. I think Neeraj helped answer all the previous one of them. So as mentioned, folks, that the Polywrap team is also on the Eat for All Discord. So while building, if you face any queries, feel free to drop it over there and folks will be there to help you out. And once again, thanks a lot, Neeraj and Jordan, for taking out the time and helping the builders learn all about Polywrap. I'm pretty sure they'd be pretty excited to build on Polywrap. And thanks everyone else for joining in as well.
Thank you so much. It was really great. Thank you so much.
Right. Thank you, everyone.